Hi everyone, it's Miss Maloney here. We're going to talk about relations and functions today. So the first thing that I want to talk about is relation because it's the more general term. A relation is just a set of ordered pairs. So I've given you 3 examples. The first example is this circle here. So a relation would be the set of all the ordered pairs that make up that circle. We could write some of them down, not all of them, but some of them. Like, for example, 2, 0 is a set of ordered pairs on that circle. 0, negative 2 would also be, that would be here. 2 zeros here. Again, I can't write them all down because there's an infinite number of points, but I could write a few down. The next example I gave you was a table. Again, this is just a list of ordered pairs, so 1, 5, 6, 12, and 1, 7. X is our input here, and Y is our output. And then the last one is an equation. Again, X is our input here, and Y is our output. And this relation is a rule, actually. It says, take our input, multiply by 2, and then add 1. So now we're going to talk about functions, which is a specific type of relation. So a function is a relation where each input has exactly one output. I'm going to give you some examples and some non-examples. Let's start with some non-examples from the previous page first. So the first non-example I want to give you is a table. This relation, or this set of points, is not a function, because notice my input of 1 has 2 outputs. It goes to 5, and it also goes to 7. That means this relation is not a function. The next non-example I'm going to give you is this graph of the circle. So in this example, there are inputs that go to more than one output. So for example, if I chose this point right here, let's call it 1. That's an X value, that's our input. 1 has a pair above it and below it. Because an X value, or an input of 1, has 2 Y values that are paired with it, or 2 outputs that are paired with it, this is not a function. A nice way of telling whether a function is a function from a graph is to look at a vertical line. If a vertical line hits more than one point, that graph cannot be a function. Let's take a look at the examples now. In the first table that I've given you, this is a function. Notice, the number 1, this input, only goes to one output. 2 only goes to one output, and 3 only goes to one output. Notice it's okay that I have 2 of the same Y values. I just can't have 2 of the same X values going to 2 separate Y values. In the graph, notice if I cut off the bottom half of the circle, now my picture is a function. If I pick any X value I want, let's try negative 1 this time, there's only one Y value that's paired with it. The last example I'm going to give you is this equation, y equals 2x plus 1. I need to verify that any input is only yielding one output. So if I choose an input, say 3, I should only be able to get one output, say 7. If I choose any other input, I don't know, 20, I should only be able to get one output, say 41. If I can verify that this is true for any input, I can say this is a function. We're going to be talking about functions all year, so let me introduce the notation that we use for functions. So I've given you an example of an equation written using function notation. F is what I'm going to call the function. Sometimes I use a letter G, sometimes I use H. It depends on what I feel like. X is the input variable. Okay, that's what I'm going to be plugging into. Sometimes I use X, sometimes I'll use T if the variable is representing time. That makes more sense. If I wanted to read this notation, I would say f of x. So I would read this as f of x equals 2x plus 1. This second part here, what this is equal to, is the rule. It gives you the output when you plug in an x value, or an input. So what you have down here are three types of representations: equations, tables, and graphs. We're going to be looking at these three different types of representations all year, so we should be comfortable with how to use them. Let's start with the equation. I'm going to ask you to do two types of things. The first type would be to evaluate at a certain point. So if I wanted to evaluate f of 2, that means my input is 2. That means I want to see what I get when I plug in 2. So the answer to this would be 2 squared is 4, times 2 is 8, so that would be 9. So what I've written is f of 2 equals 9. If you wanted to write that a different way, you could write the coordinate 2 comma 9. Okay, remember, a function is just a relation. It's just a set of ordered pairs. So the ordered pair there is 2 comma 9. We could also ask you to solve for an input. So if I said solve f of x equals 19, you would have to decide which input yields an output of 19. If I wanted to set that up, it would look like this. My output is 19. What was my input? I have to undo everything that was done to the function. Take away 1, divide by 2, and then take a square root. Note here there's two answers. X is either 3 or negative 3. Okay, let's look at tables now. Notice I called this function g of x, not f of x, so I'm going to use g instead this time. So let's see. If I wanted to evaluate g of 2, that would be saying what pair goes with an input of 2? Well, I just have to find an input of 2 and write down the pair that goes with it. If I wanted to solve, I could say solve the equation g of x equals, let's do 2 again. Notice there's two answers here. 10 is an input that yields an output of 2, and 5 is also an input that yields an output of 2. So this would say x equals 5 or 10. Last one is a graph. Let's call this graph h of x. If I wanted to evaluate h of 1, I would look on the input, meaning on the x, for the value of 1. I then have to find its pair, which looks like it's at 3. If I wanted to solve h of x equals 3, then I'm wondering which inputs yield an output of 3. So that means I need an output of 3, meaning I need a y value of 3. So I think there are 2 points that have a y value of 3, when x is negative 1 and when x is positive.